Hello, 7th graders. We are going to work with solving inequalities today. So remember, an inequality is a comparison of two values that are not equal to each other. So we spent an entire unit working with equations where you had one value equal to another. But now what we're going to be doing is solving inequalities where we don't just get one single answer, we have an infinite number of solutions to these. So if we look at this first inequality, we have y plus 5 is greater than 12. And so when we think about what that means, all right, it means when we add 5 to a number, the answer is greater than 12. So to solve this and to think through, to figure out what possible numbers y could be, we want to ask ourselves the same questions we asked ourselves when we solved equations. So we want to ask ourselves, what's happening to the variable? And then how do we undo that? So when I look at this, I see that I'm adding 5 to the variable. So to undo that, I need to subtract 5. And when I do that, my 5s will zero out, leaving me with the y by itself. Whatever I do to one side, I need to do to the other. So when I say sides, I mean literal sides of that inequality symbol. So the y plus 5 is on one side and the 12 is on another side. So I'm going to subtract 5 from 12, which gives me 7. So then our final solution here, what we'd write as our answer, is y is greater than 7. When we used to solve equations, we could just write 7 and that would be a substantial answer. Because we're solving inequalities, y doesn't actually equal 7, y has to be greater than 7. So we need to make sure that we write our solution with a variable, an inequality symbol, and a value. So let's think of some possible solutions to this. So y needs to be greater than 7. So when I think of this, I realize that 8 is greater than 7, so 8 might be an answer here. Some other possibilities are 10, 25, 135, 200. You could get crazy and say 1,000. You might just think 7.1. All of those numbers would be greater than 7, so all of those are possible solutions, okay? So then when we think about what the graph of this inequality looks like, we have an open circle at the 7 because it was just greater than 7, not equal to 7. And then we want to think of where are all these possible solutions on this number line compared to 7. So when we look here, we're at 7. All of those numbers are going to be over to the right, and that's why our arrow goes to the right on this graph. Checking a solution is just kind of a good habit to get into. So I could just choose any one of these solutions, any one of these numbers that's greater than 7, and plug it into the inequality and just confirm that it actually is true. So for example, here we plugged in 25 for the y. So 25 plus 5 gives me 30. And if I read this inequality, it says 30 is greater than 12. That's true. And so then that means that 25 would at least be a solution. So it's usually a pretty good indicator that you did things correctly. And it's just a good habit to get into. So if we look at another one, here we have, I'm going to skip that second row for now. 14 is less than or equal to x plus 30. We're going to ask ourselves, what's happening to the variable? I'm adding 30, so I need to subtract 30. And when I do that, my 30s zero out, leaving me with x. And then what's really important when you solve inequalities is just keeping track of which side you're on and where your inequality symbol is. So I'm going to bring down my x, I'm going to bring down that inequality symbol, and then 14 minus 30 is going to give me negative 16. So this would be my solution. But sometimes when we have the variable on the right-hand side, that's a little confusing. So we're actually going to rewrite this with the variable on the left-hand side and compare it to negative 16. And so when I do that, if I'm going to flip where my variable is, then I also need to make sure I flip that inequality symbol. So these two inequalities actually mean the exact same thing. Negative 16 is less than or equal to x means the same as x is greater than or equal to negative 16. This graph, we're going to have our number line. And when I think of some numbers that are greater than negative 16, I think negative 15, 0, 140, 300, all of those would be possibilities. And so when I think about what this graph is going to look like, this one will be a closed circle at negative 16. And then I want to think of where all these numbers are going to be on my number line, which is going to be to the right. When we look at some problems that involve subtraction, so 16 is greater than or equal to k minus 2.5. I'm going to ask myself, what's happening to the variable? My variable is on the right-hand side, and I'm subtracting 2.5. So to undo subtraction, I need to add 2.5. These zero out on the right, leaving me with k by itself. And then when I add 16 plus 2.5, some of you guys might be reaching for your calculators, but I know that you guys can figure this one out in your head. So 16 plus 2 is 18, so 16 plus 2.5 is going to be 18.5. Now this one's another one where the variable happens to be on the right-hand side. So I'm going to rewrite it to have the variable on the left-hand side. And again, if I rewrite it, if I flip that, I just need to make sure that I'm flipping that inequality too. So now it says k is less than or equal to 18.5, which means the same thing as that original inequality. But now it's a little bit easier to process. So I need numbers that are less than or equal to 18.5. So 18.5 could be a solution, 17 could be a solution, 16 could be a solution, 0, -5, those would all be possibilities. So when I graph this, I have 18.5. We could either write 18 and 19. You could write 17.5 or 19.5. When I graph this, I'm going to have a closed circle. And then all these numbers that we just came up with for possible solutions are going to be to the left of 18.5. These inequalities now involve multiplication and division. So we're going to look at some of these. So actually I'm going to look at this one right here, where you're given what it means, but then you have to write out the inequality. So a number k times 8.5 is at most 34. Well, at most, I know is the less than or equal to symbol. And then a number k times 8.5, the best way to write that would be 8.5k. So I end up with 8.5k is less than or equal to 34. So I'm going to ask myself, what's happening to my variable? It's being multiplied times 8.5, so I need to undo that, and I undo multiplication with division. I typically show my division as a fraction. If it helps you to write the division symbol, you can. Over here, 8.5 divided by 8.5 gives me the 1k, or just k by itself. And then when I take 34 divided by 8.5, I get 4. So k is less than or equal to 4. So when we think of possible solutions, 4 could be an answer because it could be equal to 4, or any number less. So 3, 2, 1, 0, -5, -100. Those would all be possibilities. When we graph it, we have 4. So the number we're comparing to is in the middle. We just need a number less than and a number greater than. So 3, 4, 5. And then when I graph this, it can be equal to 4, so I'm going to have a closed circle. And then I want to think of where all these numbers and all these possible solutions will be. Those will be to the left. When we look at an inequality that has division, so here I have -12 is greater than d divided by 3. And so when I go to solve that one, right now my variable is being divided by 3. I need to undo that. So I'm going to multiply both sides by 3. And when I do that, on the right-hand side, I end up with 3d divided by 3, which just gives me d by itself. I'm going to bring down my inequality symbol. 3 times -12 is -36. This is another one of those tricky inequalities where the variable is on our right-hand side right now. So I'm actually going to rewrite that so as d is less than -36. So because I flipped where my variable is, I had to flip that inequality as well. So all numbers less than -36, this would be -37, -40, -50, -62, -100. And so to graph that, I have -36 on my number line. Because we're dealing with negatives, pay attention to the order that you write your negatives in. It should be like how they would be on a number line. And then on this one, I'll have an open circle at -36. since D can't actually equal negative 36. And then all my numbers less than negative 36 will be to the left. So that's a little rundown on how we can solve one-step inequalities as of right now. There's an extra little twist when we multiply or divide by a negative. I'll make a separate video for that. Have a great day.